Alright, welcome back to the shop. It's been a day or so. Last left you, we made this part, and I learned some lessons on the counterboring process. So I've got a different cutter for the next part. This is 21/64. I got these off of eBay. I bought a bunch of them because they were super cheap. And they have a really nice smooth flute. So my hope is that they do pretty well for chip ejection. My hope is that they do pretty well for chip evacuation. Yeah, so there's a slight curve, but they're not spirals. Hopefully they do all right ejecting the chips. And I've got a bunch of them, so if I go through them, I don't mind. But they're significantly smaller than the diameter of the counterbore, so that'll allow for chip clearance instead of it being a massive plunge move. So the next piece is, this is the table, or also the Y carriage. This will be the X, actually this is the Z carriage. This is what goes up and down. Yeah, this goes up and down. And it's going to be what the spindle gets mounted to. So I've got that. It's the small part that I've got. I can register against this cut area, so I can get it parallel. It's the same situation. It's a very small part. So I have to get my X and Y center, X and Y 0 really accurate. So I've put the V-bit back in the spindle. But the first cut will be with this to cut the counterbores. But the V-bit gives me a very good, an easy way of getting a very good 0 for X and Y. So we'll just get this little part mounted down. This is actually kind of fortuitous that I went after it this direction in this sequence, because I think I'm going to flip this, because it, yeah, that's more stable. I went at it in this sequence because I cut out this channel for a larger part and then went to a smaller part, which is interesting. It just kind of worked out. So we're going to get this screwed down. To do that, I'm going to put this bit in, and this whole spoil board thing is working out really well. I can chew it up as much as necessary. This is another one of those that is like the table, where there's a bunch of counterbores in each corner, so I have to mount in the centers again. And I'm just going to drill some new holes because those are too close for it, and then we'll get things mounted. Okay. And this is not a lot of critical thing. This is just so it stays put while I do the counterboring, and then we can do the outer profile after that with the screws removed. So I'll start my screws first. Ooh, this battery's dull. Then we're gonna go get a new battery. I'll be right back. Okay, back with a sharp battery. I don't know why I said dull. It was dead, not dull. I don't know what made me say dull. But yeah, sure. See how sharp that battery is? I guess we have sharp batteries and dull batteries now, because I guess I'm a dork. Anyway. Anywho. That, yep, where's that? Alright, I'm gonna get the air going, get some hearing and eye protection on, and cross my fingers and hope this goes as well as I'm hoping it will do. Cool, that cutter worked really well. The part is incredibly warm right now, and I mean, the quality of the bottom isn't great. It's not bad, it's fine. It's flat enough. The wall side, the side walls are really nice. This part is really, really warm though. It put a lot of heat into it. So I'm thinking part of that might have just been because I had the speed up so high, because I wanted to baby the cutting edge and the machine, because it's not rigid enough for a heavy chip load. So I think part of it was speed helped a lot, and the air blast kept the chips out. So what I'm going to do is I'm going to bring the air blast over to give the part a cooling down, and then we'll switch out to the V cutter and get it ready for poking a couple of, well, marking where all the holes go, and then I'll drill a couple so I can mount it, and then we can do the outer profile. These counterbore locations are quite close to this edge, so I have a feeling I'm not going to cut this edge again. Maybe. I'm not entirely certain why that's continuing to happen. I have the dimensions of this workpiece in my cam, and I centered the model, so why this isn't coming out centered, I'm a little unsure. Well, I'll go back and check, but for now I'm going to cool this part off so I don't have any troubles with profiling later, and I'll bring you back here in a second. I'm quite pleased by the counterbores though. That process worked a lot better. Alright, we've got our V-carving bit in here now to spot all the centers for each of these holes. Pretty simple operation that I might be able to do quietly. So let's see. Let's try it. Ready, set, go. Might be a little loud. Yeah, see, just pop in each hole. This doesn't take long at all. I find it interesting that it chose this whole pattern for the spotting, but a totally different pattern for the counterboring. Kind of an interesting thing. And there it is. And then we'll change it out again for the end mill. And we'll do the cutout for the profile here after I drill for my holes. Let's do that now, shall we? Real quickly, we got to drill a couple of holes so that we can hold this thing down, So I'll just real quick switch out this bit here. Just get this drilling going so that we can... Yeah, that's machine's in the way there, isn't it? Again, these are going to be drilled oversized intentionally anyways, so I don't need them to be perfectly concentric. As long as they're, you know, within my ballpark, I should be fine. I want some slop because I want there to be some adjustability, because one of the things that's tricky with those bearing trucks is getting the 4 of them aligned in a way that the machine travels right with no binding. So basically the rails have to be parallel, and then all of the trucks have to be aimed in exactly the same direction. So it's, you know, a little adjustability is not bad here. Come on. And we're just making sure we don't move anything while we're doing this, because the X and Y zero need to stay put. So then we can take this and go right there, and we can do this and go right there. And now we can come back and remove all this. And our part is now securely held by that. And next is to run our profiling code after we change the cutter. So I'll bring you back here in just a second. forgot to mention, anyway, it's part's done. It came out pretty good. I forgot to mention that this was a part I was trying on the profile cut going around the outside, that profile cut. I was trying, it went the other direction. It was a climb cut instead of a conventional milling cut. And I wanted to see what kind of surface it left. And I feel like, while it's got some ridges, it still didn't cut this edge, which is fine. It's got some slight ridges, but I feel like it did a better job than I expected it to. So what that means is, I think we're going to go set up all the other G-code to cut climb cuts for those profiles as well. But ultimately, came out pretty good. I'm going to go deburr this thing, and we're going to get set up for the next part. So I'll be right back in just a sec. Alright, that part came out good. Next part is the Y-axis plate. This is going to hold the rails for the Z and the screw for the Z. And it's going to have bearing trucks on one end and the angle bracket on the other end. So this is going to have a fair number of different holes. I've got the V-grooving bit in place. We're going to get it mounted down. This is getting a tad repetitive now. So I'm going to just get after this part the same way I've done on the last ones. And we should be pretty good to go. So I'm just gonna go for it, and I'll probably just have some music. So here you go. Alright, that one went alright. It wasn't as good a cut as the last part was, but it still held up. I think it's fine. It is fine. Not a big problem. This one cut nice-ish. Didn't cut that great. It's a little bit of recutting in a couple of spots, not too bad. Climb milling was a lot better at this point. I can say that for sure. It's got a little warm, although the part stayed relatively cool the entire process, which was good. That's what I was worried about on these bigger pieces, is soaking up so much heat. So the next three parts, one of them might be just like this, very edge cut. But the last two parts are going to be heavy slotted, so I might have to pause them. But hey, we got another part. This is part number 6. Only 3 to go. Alright, here we go. I'll go deburr this, get set up for the next part. Okay, so the last part, the observant of you, or the watchful eyes that you might have noticed, I didn't actually do climb cut on that last one. And that's why the edge wasn't as good as it could have been. I forgot to bring the G-code over from the machine after I regenerated it when I decided it was time to do it as a climb. Messed that up a little bit, but that's no big deal. They're all now over. All the remaining parts are over. This is probably the simplest of the big parts. We're into the frame now. This is the bottom of the frame. This is the base, and then we've got the 2 sides left. That's all the parts left to do. So we're just gonna do like I did before, and just mount this down. This one's actually really nice. There's only 4 holes, I think, if memory serves. This only has the 4 holes because I don't have. I'm not confident in the spacing on the rails to put in mounting holes. I'll do those manually. As much as I'd like to have them parallel, I'd actually rather let the machine be the parallelism. So it's really just the bearing blocks. There might be 6 holes if I recall. Yeah, I think there might be 6. So there's just a few pecks, no counter bores, just a few pecks. I'll drill, screw it down, and then we'll do a profile around the outside. It's kind of an obnoxious part to be doing on the CNC because it takes a while, but it's the safest way I know to get those things where I want them at the right lengths. We'll figure out a way to get that to work. Okay, last two parts. So these are tricky because basically the part is kind of a trapezoid or a polygon of some kind. It's got a diagonal. It's going to run on this part. It's going to run this way. I think the other part it's going to go this way. And it's going to cut away everything from these three edges, which means, ooh, we've got a really bad corner here that would suck to get a X and Y from. So I'm going to spin this bugger completely around because this corner is a little better at least. And so we're going to register against those two corners like so. Like so. And then register off this corner's X and Y. But this diagonal that is coming here means all the part up here, here, and here is getting cut off. So I can't grab it from this side. What I'm worried about is if I put the way I've been doing the screws is having the washer pushing, that's putting a bit of force this direction. So when this cut's clear, that's going to push this offcut into the cutter. Bad idea. And jam it all up and it'd be a mess. Trying to predict that ahead of time. So what I'm going to do is I'm going to come in and I'm going to drill a couple of holes in the corner. These are corners that won't get touched. They won't even come close to the cutter at all. In fact, just to be safe, I'm going to come up here just in case, because it doesn't, I mean, it's a 1/2 inch cutter, so it's probably not going to reach it, but I don't want to take any chances. I'm going to come up here and here and just get a couple of holes, a couple of screws in here. Oops, great. And the idea then is I can mount these sides and not have to worry about the shifting. About the offcut shifting is my concern. I can come in this far if I want to. It doesn't really matter. In fact, I will. Okay. And then we'll switch out the bit for the bigger one. Doing it in 2 steps helps it align, but doesn't really matter too much here, but did it that way. And this way. Okay, now we can get it right where I want to get it. I want it to sit fairly parallel with this axis. Doesn't matter too much as long as I get my X and Y in decent spots. Then I can stick some screws in. That one's good. I go with somewhat longer screws here. Oop, we shifted a fair bit there, but I'm okay. No, I'm not okay. Not happy with that. We're gonna shift this whole mess about a hole size over here. And that's my only possibility right there. Let's try our best. That's pretty good. And this one, try not to shift in. That's good. That'll work. All right. Okay, so now that side of the part is held down. I'm going to come over here with my standard washers and screws that I had been using until I can get holes into this. This is not super critical at this point because those 2 screws are pretty much keeping it from going anywhere anyhow, but I want to get a couple of screws in to hold it down and not have to fight with that at all if I can help it. That screw doesn't work real well. That hole's in a bad spot for that piece. Not a big deal. Okay, that's a good enough hold. And now we're going to switch back out and do the same thing I've been doing. We'll put the V-bit in and mark for those holes. Drill this down. I'll bring you back when the next sort of thing I would talk about. Well, yeah, we're going to have to cut that diagonal, which is going to be a slotting cut. So we'll see how that works. We'll see how that behaves. All right, bring you back in a sec. All right, this is the right frame holes. I did exactly the same thing and inverted it in a mirror image. So they're screwed down on this side and the screws and washers are on that side. We're going to do the hole marking and then I'll drill and then I'll mount it and then we'll do the same cut we just saw. So in a mirror. So we'll bring you back. Well, no, here, have some music. All right. Whew, okay, well, that's the last part there. It's done. Cool, that one turned out even better than the last one. That went smooth, very smooth, now that I've figured it out. But I'm good, I'm happy with this. The machining on the big parts is done now. We can pull this all apart and I can get back to making branding irons with this machine while I build the new one. Cool, I'm very pleased, I'm very pleased. Let me get this deburred. Snap a couple of pictures and I'll work through what the next steps are after that. Alright, be right back. So I keep doing this but I didn't show it, so some of you might be wondering what I mean by going in deburring. There's this little handy tool. Looks like a hook and loop needle to me, like, you know, those hook and loop rug things, focus you back, you know, but it's a really sharp, really hardened sort of, works really well for everything I've needed it to do. So this little guy deburrs the sharp edge. Watch, it's pretty cool. See the little curl? Now it's pretty much safe. I go a couple of times because if you angle it just right, you can get it to kind of favor the top half, and if you angle it the other way, you can get it to favor the bottom, the facing half. And it works pretty well both directions. Let's get some on this side a little bit. And then it's very safe. You can run your hand over it. It does no slicing whatsoever. This is an awkward position. We can do this edge. So I kind of run over it a couple of ways, a couple of times from different angles, and it makes it so nice to touch. It feels. It's very safe to grab and handle the parts better. Because when you're flinging these things around, you know, you want to put it in the mill or whatever, it's dangerous to grab onto these things sometimes. And so you want to deburr them. There we go. That's nice. And you can do you can use a file to do this, but these little guys make life really, really easy. Nothing to it. So these are the things I prefer to use if I can. It also, I'll show you here in a second, it also makes doing round holes really nice and easy as well. So check this out. You just go. Deburring a round hole is really nice. A curve of any kind is really pleasant. This side. It's really, the only trick is getting the angle that you're pulling it at right, in a way that it likes it. And other than that, it works great. Favoring the top, favoring the side. Very nice deburring. Mostly top. Yeah, and that comes out good. You have to kind of do a little bit on the ends, but that's minor. And then what I can do now is, I can't do these edges yet because I haven't really done well, but I can come in and file these corners because catching these little corners is tricky, so it's just easier to file them. But it cuts down on how much filing you got to do, so that's nice. Okay, I've done this side and I've done this edge. I haven't done this edge or this edge, so I'm going to tilt it this way so I can do this edge a little. And then I'll tilt it back the other way so I can do the other edge a little bit. And you just kind of, with a little bit of practice, you can use this very effective tool. If you don't have one, I highly recommend it. This one's a no-go. You can get them cheaper. I have never used any other than this one. I can't attest to how well the other ones work. But, oop, keep dropping stuff. Where'd that one go? Way under the tank. Come here. I really should put magnets on those. I use them enough. Those jaws. There we go. That one was a good one. Favoring the top a little bit. We'll favor the underside. That's nice. We'll do this side. There we go. You can even do these little holes. That helps a bit. Keeps the sharp burrs from cutting you all up. And there we go. Oh, we gotta do a little more there. You can kind of go in an arc shape when you do it. This is filed. This needs filing. And there we are, one other part completely set. Ready to drill all the holes that it needs.